Welcome to the JCE Connect. In this session on velocity and mechanism, let us go through the instantaneous center method. Hello everyone, I am Ratan Patel from Mechanical Engineering Department, Jain College of Engineering, Belgaum. In the previous session, we had an introduction on instantaneous center method and how to determine the number of instantaneous centers. So in this particular session, let us see how to locate the instantaneous center. On the screen, we are having figure 1, and the figure 1, we are having separate cases. In case A, we are having two links, link 1 and link 2, and both the links are joined using a pin joint or a pivoted joint. So in such cases, the instantaneous center lie exactly at the center of the pin or pivoted joint. And the type of instantaneous center is permanent instantaneous centers, as none of the links are being fixed there. If in case link 1 or link 2 is being fixed, then the type of instantaneous center will be fixed instantaneous center. Now in case B, we are having a disk here, this one, and this disk is rolling without slipping on fixed link 1 there. So in such case, the instantaneous center lie exactly at the point of contact of the disk and the fixed link. So if at point A, or we are required to find out the velocity, then the velocity of point A is proportional to I12 into A, that is the distance between them. In third case, we are having a slider here, and this slider is going to slide over the fixed link, and this fixed link is straight. So in such cases, the instantaneous center lie at the infinity as been shown here. And if you take any point on the slider, either point A or point B, both the points will have same velocity. In fourth case, that is in figure D, we are having a slider, and whatever the slider is there, this slider is going to move on curved path there, and that curved path also is fixed, but it is not straight. So in such cases, whatever the instantaneous center is there, this instantaneous center is going to lie at a particular point, and that point is being called as center of curvature. As we can see from point A and point B, if we draw the instantaneous centers, they are going to intersect at a particular point, and that point will be center of curvature known as I12. Now in the next case, we are having again a slider that is linked to, and whatever the slider is there, this is going to slide over fixed link there, and whatever that fixed link is there, it is having a circular path. So the slider is going to slide, and if you take 2 points A and B, and with respect to 2 points A and B, if you are required to have the instantaneous center, it is going to be I12, and whatever this instantaneous center is there, this instantaneous center is going to be at the center of this circle. So these are some of the cases wherein we can locate the instantaneous center with respect to a different kind of cases. Now in the next case, let us see the Arnold-Kennedy theorem, or it is 3 centers in line theorem. So the theorem states that if 3 bodies move relatively to each other, then they have 3 instantaneous centers and lie on the straight line. So we are having the 3 links here, link A, link B and link C. So if you want to find out the number of instantaneous center, we can find out using this particular equation here, n equal to n minus 1 divided by 2. As the number of links are 3, therefore n equal to 3 here. Therefore the number of instantaneous centers are 3. Now we are having 2 instantaneous center here. Now with respect to link A and B, it is IAB. With respect to link A and C, the instantaneous center is IAC. So this is IAB and this is IAC. And both these instantaneous centers are permanent instantaneous centers. Then according to the Kennedy theorem, whatever the third instantaneous center is there, whatever this IBC, must lie on the line joining IAB and IAC. So in order to prove this theorem, let us consider that instantaneous center IBC is going to lie outside the line joining IAB and IAC. The point IBC belongs to both the links, link B as well as link C. So let us consider the point IBC on link B. Now its velocity, velocity that is VBC, is perpendicular to the line joining IAB and IBC, And similarly, if we consider IBC point on link C, then the velocity VBC is perpendicular to the line joining IAC and IBC. But we know that the velocity of the instantaneous center is same whether it is regarded as a point on the first link, that is B, or either on the second link, that is C. Therefore, the velocity of the point IBC cannot be perpendicular to the both lines, that is IAB and IBC, and second line is IAC and IBC. Thus, the three instantaneous centers, which are IAB, IAC and IBC, must lie on the same straight line. But in order to have all these three instantaneous center on the same straight line, the exact location of IBC on line IA, B and IAC depends upon the magnitude and directions of angular velocities of link B and link C with respect to or with relative to link A. Now, in the next case, let us see the method of locating instantaneous center in a mechanism. So consider a 4-bar mechanism wherein we are having 4 links as shown in the sketch here. So since the number of links are 4, first let us determine the number of instantaneous centers using this formula here, and the number of instantaneous centers turns out to be 6. So whatever the 6 instantaneous centers are there, let us group this or make a list in the second step. So we are having 4 links. So write this 4 links as being shown in the table here. With respect to link 1, we can write instantaneous centers as I12, next is I13 and I14. With respect to link 2, it is I23, I24, and with respect to link 3, it is I34. So instantaneous center I12 is same or it is equal to I21. So there is no need of writing repeated instantaneous centers. So this is one at the same. And similarly with I13, I31, I14, I41, I23, I32. So the total number of instantaneous centers are been grouped here and they're totally 6. Now once we have determined the or listed the total instantaneous centers, let us have the fixed instantaneous centers and permanent instantaneous centers. So we are having a 4-bar mechanism here, and we are having link 1 and link 2. So link 1 and link 2 is having instantaneous center I12. Link 2 and link 3 is having instantaneous center I23. Link 3 and link 4 is having instantaneous center I34. And link 1 and link 4 is having instantaneous center I14. So based on the inspection method, we have fixed I12 here, I14, and these are called as fixed instantaneous center. And there are 2 more instantaneous centers, I23 and I34, and these instantaneous centers are permanent instantaneous centers. So out of 6 instantaneous centers, we have located 4 instantaneous centers, that is I14, I12, I23 and I34. So this is I14 we have fixed, I12 we have located, next we have located I23 and I34, I23 and I34. So we are left with I13 here and I24. So we are required to locate these 2 remaining instantaneous centers. So in order to locate these 2 remaining instantaneous centers, so what we will do is we draw a circle, and since we are having 4 links, we will name this 4 links: link 1, link 2, link 3 and link 4. So once we have named this, what I'll do is that let us join these links. So by dark lines, that is, this is link 1 to 2, link 2 3, link 3 to 4 and link 4 to 1, or it has been named as link 1, 2, 3 and 4. So in order to locate the 5th instantaneous center, I'll draw a dotted line between points 1 and 3. So we'll be having 2 triangles, that is triangle 1, 2 and 3 and triangle 1, 3 and 4. So using these both triangles, so we are having triangle 1, 2, 3. We are having 2 instantaneous centers. One is I12 and I23, and triangle triangle 1, 3 and 4 is I34 and I14. So using this, we are having 2 two sets of instantaneous centers. So for this is I1 to 2 here and I2 3 here, using this triangle, this one, and using this triangle we are having I14 and I34. So whatever instantaneous centers we have got, with respect to these instantaneous centers, project these lines, and when we project both these lines, they meet at some particular point, and at that particular point we get the fifth instantaneous center, and that instantaneous center is I13, this one, I13. So we have located now fifth instantaneous center. So similarly we are required to locate the sixth instantaneous center. In order to locate the sixth instantaneous center, we are required to join points now 2 and 4. So when we are required to join points 2 and 4, so we'll be again having two triangles. One is triangle 1, 2 and 4, and other one is 2, 3 and 4. So now using these two adjacent triangles, so if I take triangle 1, 2 and 4, we are having instantaneous center I12 and I14. So this is I12 and I14, and we are having another triangle here 2, 3 and 4. So we are having instantaneous center 2, 3 and instantaneous center 3, 4. So instantaneous center 2, 3 and instantaneous center 3, 4. So what we can do is that we can project these lines, and after projecting whatever these lines are there, these lines are going to meet at some particular point, and that point is I24. So that will be the sixth instantaneous center. So now we have located the total 6 instantaneous centers. This is the method to locate all the instantaneous centers. Thank you.